OUKITEL have sent me one of their early production models to review. This is the Abearl P5000. This solar generator is advertised as having 5,120 watt hours. Now that is big. And as of the filming of this video, it has a better dollar per watt hour value than the competition. Better value than the EcoFlow Delta, better than the Bluettis, and better than the Jackery. The closest competitor I could find is the Bluetti EP500 Pro. It comes in at 5,100 watt hours, but it is currently selling for about $4,900. Today, the Abearl we're looking at, if you can get the Kickstarter promotion, it is about $2,900. If you are in the market for a large solar generator that could potentially run your house in an emergency, this unit is worth considering. It might be hard to tell on video, but this thing is big and it's heavy. It's 110 pounds and it is about 10 times the capacity of your standard camping style power generator. We will take a walk around this unit. This end got some vents, and here is a handle. You got to push the button. Come on, there we go. Here's a handle that pops out. It does have wheels in the back, so you can get it moved around without too much hassle. And my goal of this video is to see, can it do what it says it can do? Is this something you can trust to maybe run your, maybe you want to build an off-grid cabin, or maybe you have a hunting shack you're building. This would probably be perfect for something like that. So we're going to check this thing out. And like I mentioned, it is 10 times the capacity, but it is not 10 times the cost. So this is worth checking out to see if this is something you might want to buy someday. Look at that. MC4 connectors. Thank you. And there's the other end for the DC. So this would be a no-hassle hookup for solar charge. In other words, you just buy a solar panel and plug this right in without having to make adapters. Nice. And then what else we got in here? DC cigarette lighter, so we can charge this cigarette lighter. And look at this AC cord. Yeah, it might be kind of hard to tell on video, but this cord is definitely heavier. Okay, this is a 14 gauge wire, and it does claim a super fast charging mode at 1800 watts. So with your average 15 amp breaker on a 120 volt circuit, that is completely maxing it out. This thing can charge as fast as the outlet will allow it to, according to what they claim anyways. We'll see if that's true. The AC inverter that is in this unit is rated for 2200 watts. Now that is the continuous rating, not the peak rating. The peak rating is somewhere around 4000. Now that's a good number, because that means basically if you have something that has a 120 volt plug on it, this will run it. It'll do it. It's over an outlet rating. So you can run your air compressor, heck, maybe even your welder, as long as it has 110 volt plug, this should run it. And this is also, it looks like this is just 110 volt also, but this is a 30 amp, rated at 30 amp plug here. Their marketing push with this plug is that it can charge an electric vehicle. Over here is DC output. So this is a 12 volt cigarette lighter plug. You can run your 12 volt devices, and this is 24 volt. That's interesting. It's a 24 volt. They're both good for 10 amps each, and these are just barrel jack 12 volt outputs to run, your little devices that like those. And here's your cell phone stuff. USB ports, USB-C. They also claim the battery chemistry is lithium iron phosphate, which as of the filming of this video, lithium iron phosphate is the best battery technology we have available. So I'm going to open it up and make sure that's what's really in here. And I think the walk around is done. Let's just take this thing apart. Jeez. Here's the first view with the lid off. It looks like the inverter is on top, but I do see another board at the back. Here we can see it has a total of 4 fans. 2 more over here. All right, well, from what I can see right now, it looks pretty good. I see nice heavy wire running everywhere. It's even silicone insulated, which feels nice. Here is the battery balance board, battery management right on top. And I'm going to take this thing apart a little bit further. There is our first peek at the actual cells. You can see they are the square lithium iron phosphate style, and they're completely enclosed in an aluminum shell, and it's quite impressive. It's very well done. Here's the bus bar for joining the top and bottom cells together. Here's the positive, which is dual 10 gauge silicone. Feels really good. And this is the negative bus bar going up to the balance board. This board here is the solar charge controller. So here's a solar coming in. So this is a 1,000 watt MPPT. And also this half of the board over here is doing the 24 volts and 12 volts for the DC output on the front panel. And here on the main inverter, we can see a couple temperature sensors. This board itself also has 2 cooling fans with a little tunnel to direct the air. The full battery voltage is 51.9 volts. There is 16 cells going into this balance board, and if I check the first cell, I'm getting 3.2 volts, so that does check out as lithium iron phosphate voltages. The power going into the inverter is doubled up 10 gauge, very nicely done. And you got to remember, at 51 volts, there's not a whole lot of current going through here, so they could have cheaped out, but they didn't. And here, this yellow wire, this is a ground wire. It actually follows all the way back to the AC receptacle. So they put an effort to ground it. Not only did they put an effort to ground it, but they use some heavy-ass wire, which isn't necessary because there's nothing to ground it to. I mean, you can ground to the ground chassis of the inverter, but, you know, it's just going to the metal chassis of the box, which is a double insulated plastic box anyways. But whatever, they put in the effort to ground it, which is the first time I've seen that in a portable power station. And here is the AC out, which they're using 12 gauge wire, also silicon insulated, nicely done. It looks like the AC in and the AC out are both 12 gauge, including the ground wire. So this inverter board here is a bidirectional one. So not only is it in charge of the 2200 watts AC coming out, but it's also in charge of the fast charge coming in. And here we can see a bank of relays that would be in charge of that switchover. And this is set up for UPS. So this is also can be used as an uninterruptible power supply source. With just the single AC output, this is not a split phase setup. This is just a single phase 120 volt. So this cannot do 220 at the same time. That is worth noting. And now I'm going to put this thing back together. We're going to do some capacity and load testing. I now have it set up for AC fast charging. Front panel says we are pulling about 1500 watts. And my kilowatt meter agrees. 1500 watts charging, and we should be done in a couple hours. It has been charging for about an hour. Fans kicked on about 10 minutes in. We're at 65%. I'm going to do what I call the UPS switchover test. So right now, I have it powering the Xbox, and it is currently taking the wall outlet AC and just running straight through to the socket. So I'm going to see how fast it can switch over if the grid goes down. So I'm going to pull the cord out of the wall, and if it switches over fast enough to its own inverter and battery, the Xbox shouldn't be disturbed. It should be able to stay on its home menu If it crashes, well, then the switchover time is too slow. So this would be equivalent to like a desktop PC if you wanted to use the uninterruptible power feature. So here, I'm going to grab the cord. There's the home menu, and we're unplugged. So it did it. It was able to switch over fast enough that it didn't interrupt the Xbox. And the Xbox is using about 50 watts, 46 watts. I have just started the capacity test. It's going to be a bit of a stress test too. We are currently pulling about 1200 watts, and the kilowatt also agrees right around 1200. The heat gun is set to high. It's cranked up as high as it goes. Got a nice glow there, and stopwatch is going. There we go. So we just see how long it takes to run the battery down at 1200 watts. 4 minutes remaining, 1%. Still holding steady at the 1200 watts at around the 110 volts. That's still at 110, even though it's at 1%. And we are at 3 hours and 45 minutes. It has been sitting at 1 minute for almost 10 minutes now. It just keeps on pumping out the 1200 watts at 110 volts. And we're getting really close to the 4-hour mark. Still just going to town. There it is. Finally just quit, and we are at 3:58. 3 hours and 58 minutes. 1200 watts for 4 hours comes out to 4800 watt hours. So in 1 hour it'd be 4800. And that does seem to be what I would expect when you account for inverter efficiency loss. So it does look like you are getting the 5120 watt hour battery. So here, let's fix this. $4,800 usable watt hours. There. The solar charge input is good for 1000 watts. So that means it can go from 0% to full in about 5 hours, since it's a 5000 watt hour battery. That's pretty decent in my opinion. It's pretty easy to get 5 hours of daylight. And the input voltage is good up to 120 volts. That means you can use real full-size solar panels. You're not stuck using those small, 12 volt, 100 watt ones. You can use a full-size solar panel. The DC input is MPPT style. It does spend the first minute or so kind of hunting around looking for the maximum amount of power it can pull. I've switched over to the cigar lighter just to show that it can charge off of your cigarette lighter. I'm pulling 8 amps? 8 amps at 14 volts about. So we're looking at 100 watts through the cigarette lighter charge. It's slow, but it's an option there if you need it. Water pot's turned on. 1250 watts. Air fryer. Oh, we're at the 2200. 21, it's beeping. Seems to limit itself to that 2200 watts. I'm going to check the voltage and see if the voltage is dipping. Yeah, 99 volts. Now if I turn that off, I should turn that off. They're back up to 110. So it regulates its wattage by lowering its voltage to not exceed the 2200. Let me try that again. I'm just going to turn everything back on. So we're back at 1255, Well, no. I'm sorry, that's voltage. That's why it looks so weird. Okay, back to wattage. Watts. Okay, 1237. It's fine. It's boiling the water. Air fryer should start. And it's it's beeping again when it's exceeding its wattage. Come on, start. There we go. Okay, so that's confirmed. 2200 watts is its hard, consistent limit. It just lowers the voltage to maintain the 2200 watts, but it keeps on running, which is good. It doesn't just hit a wall and stop and shut off. It just limits to 2200. So I've spent some time with this unit, and if somebody were to ask me would I recommend it, not exactly this model. With this model, I think the inverter is a bit underpowered. Have a look here while I try to run my air compressor on it. Now I want to see if this thing can start up my air compressor. My air compressor has a small tank but a decent sized motor. It's a 1.5 horsepower. And oh no! Can't do it. Fail. But they do make a Pro model, which is the exact same battery, but a stronger inverter. The Pro model can do 4,000 watts continuous, and it's split phase. So if you do need to supply your house with power in an emergency, the split phase unit can power your 240 volt stuff also. So if you have like a well pump, you'll be able to keep that going. And I'd have a lot more confidence in that 4,000 watt inverter to kind of do everything you need it to do. Because other than the inverter only being 2,200 watts, this is a pretty good unit. The battery's impressive. You're gonna have a hard time finding a single unit, an all-in-one unit with that kind of capacity for that kind of price. Now, also, this is a no frills model. There's no Bluetooth, and there's no battery expansion port. So it's kind of a bare bones, but a good value unit. Now, this non-pro model would be fine if you don't need to run large appliances or large motors like, say, a saw or something like that. And then since this unit is 4,800 usable watt hours, that means within a 24-hour period, you could burn 200 watts for every hour within that 24-hour time period. So technically that would be enough to keep your furnace going and to keep like your refrigerator going for a full day, and you wouldn't have to worry about the limits of that 2200 watt inverter. So it is still a viable option. And if you do want to purchase this model, down below I'll have all the links to follow to their Kickstarter to get the good price, and then there'll be links to their website also. I think that covers everything that I wanted to talk about with this model. I appreciate you all for watching, and we'll see you next time.